Okay, so the very first thing to do in R-JTAG on this nice fat Jasper Modern Warfare 2 console is going to be to load up the Team Executor tutorial, since they invented this hack, and read. We'll skip and assume that you've read it a couple of times, but now have noticed that your minimum dashboard required is 15574. This does only work on HDMI consoles, so the Xenon without HDMI is not able to be done. But if you can see right here, I do have an HDMI port on this model. So, first thing I need to do is go ahead and power it up. And this console's already got a white modded LED, but that doesn't matter. So when the Xbox boots, we are completely stock at this point. We want to go ahead and check our dashboard version. We do that by scrolling over to the Settings tab, going into System, Console Settings, and System Info. We can see we are on 16203, which is actually the newest dashboard version, but the main point is that it's past the split CB of 15574, so we now know that this console can indeed be R-JTAGed. So, what I'm going to do now, off camera, is crack open the case, get the Xbox down to its motherboard, and we will start with installing the first QSB. I'll resume there in just a moment. Okay, so what I've done now is disconnect and disassemble the Xbox down to its core component. I've removed all the screws on the bottom so the motherboard is loose. The screws out of the front for the ring of light board, so that can be easily removed. And all of the internals, the SATA connector and the power and everything. What we need to do is go ahead and prepare to install our QSBs that'll let us read the NAND. Now this can be done with the wire install method, but if you bought the R-JTAG kit, I'm relatively certain that it always comes with these QSBs. I know the Ultimate kit does, because that's what I purchased, because I didn't yet have a JR programmer. So the header that we're going to prepare here is just like when we do reset glitch or anything else, is to interact with the NAND. It's this J2B1 header, as well as the header that's right in here, which is the J1D2 header. So these and these. What I'm going to do first is actually just use a fiberglass scratch pin to pick up and just kind of clean up these points a little bit. They're by default have a little bit of a coating on them that can make soldering to them a little difficult. So we're not going so far that everything turns coppery or whatever, you'll ruin your board that way. But just a good little brushing over will make these contacts a lot easier to be able to adhere to. So we'll do the same thing with this bit. Be careful of your capacitors here. These could be knocked off and be a huge pain in the butt to get replaced. Alright, so now that I got my points prepped, I'm going to go ahead and set up to solder on the QSBs, and we'll resume with that here in just a minute. Okay, so what I've gone ahead and done here is on the QSB that's going to go on this pin header, I've actually taped off the small segment that connects to the B point normally. This is just the V3 QSB, which was originally designed for use with RGH, and the point B, the standby click. But that's not necessary with the R-JTAG, so I'm not going to solder it down, and I just wanted to make sure it didn't make connection and mess anything up. Probably absolutely unnecessary to tape it off like that with just a little bit of Kapton tape, but so once that's done and in place, I've also fitted the little adhesive pads to the bottom, just so that it'll stick down in place where I want it to go. So with that in mind, I'm going to go ahead and remove the backing so you can see just the adhesive hanging out here. Sometimes a X-Acto knife is pretty handy for separating those. So now I've got adhesive remaining on the QSB, and I'm just going to go ahead and real carefully line it up.
and place it down. The adhesive isn't really meant to hold it permanently. I mean, your soldered joints are going to do that. In my mind, it's mostly just there to hold it in place while you solder it. So now that that's down, I'll go ahead and put a little bit of flux over this bad boy. So I'm just using some standard tacky flux. This is Kingbow brand, I believe. But you can use whatever kind of flux. So there I got one row of solder points. I managed to flux my ground pad just a little bit. No big deal. Or tin it rather, not flux it. Alright. So there's my primary points there. I'm gonna go ahead and use a Q-tip and just kind of clean up a little bit. Yeah, it looks pretty decent. So now I'm going to need to install the other QSB, which is actually done down around this point. Now this one, the QSB that they provide actually has the hole for the slot over the capacitor. I've gone ahead and attached the little U-shaped adhesive that they give you. So now I'm just going to pick off the protective padding. And there it goes. So now it's all sticky. We're going to want to be careful with it when we place it. Get it down on there correctly. Alright, looks okay. So once again, after it with the flux, and we'll go ahead and install this QSB. That solder joint keeps turning cold. Clean my iron off a little bit. Alright, that looks okay. Not the greatest, but certainly functional. Grab a new Q-tip. Clean this one up a little better. Alright, so these are both of the QSBs that we need in order to read the NAND. So now we can see that we've got our QSBs installed, which we just went through, and all I've done is plug in the little pin headers to my JR programmer. You can ignore this one right now, it's not plugged in anything. I just don't like stressing the connector and unplugging and replugging it. So pin headers, they're color coded. If you can't figure out how to plug those in, you should stop and send it to somebody now. So it's plugged in, everything's good. Don't have power connected at the moment, but I do have JRunner up with my JR programmer detected and everything ready to go. So I'm going to go ahead and connect power, and then we're going to hit read NAND. We see our flash config CB version. I've got number of reads selected as 2. So we are now in progress reading the NAND. I will come back to this when it's closer to done with the second read. Okay, so just so you can see, it has finished with the first NAND read through. I've got one in my output folder. It's working on the second one. One thing that I am noticing is that the JR programmer is significantly slower than the NANDEX, so I think moving forward I'll continue to use my NANDEX for the dumps, but the JR Programmer V2 is necessary for the rater function. So we'll come back when this one's closer to finishing. Okay, here we are picking up towards the end of the second dump here. It's pretty close to ending. You can see I've got my first one. It's loaded there in the source file. When the second one finishes, we should have 2 good matching dumps. Alright, so NANDs are the same. Great thing to see here. We got 2 matching dumps. I'm going to go ahead and disconnect power from my computer. And then one thing that I really like to do and suggest is grab a copy of the NAND and put them in a folder that JRunner isn't going to dick with. Because just in case something goes squirrely sideways, you know you've got a good copy of the first original retail dump somewhere other than your output folder where you can reprogram it if necessary. So the next thing I'm going to go ahead and do is to the post connections right here. I'm going to fit my post QSB. Now this has already got some adhesive on the back of it that I've placed, and I'm just going to go ahead and real carefully line it up, and then we'll solder it in a moment. Okay, so there's my QSB all lined up and down on there. Across all of these. So it's going to be difficult for me to get a good angle on this while soldering, but I'm going to give it a shot, I guess. So I'm going to go ahead and drop my flux in. Grab my solder. See what sort of magic we can work. all pretty decent. Now, these seem like they're just anchor points. I don't see traces running to anywhere. And this is really stinking solid. I'm kind of hesitant to even really worry about the anchor points, but I'll go ahead and see if I can at least do this one. Give it a little bit of twisting resistance. Yeah. I'm just kind of worried that I'm going to end up causing more damage than doing anything positive here. I'm going to go ahead and see if I can put a little bit of flux on this one. This one seems closer to the anchor point. There we go, that one grabbed. Clean off some of the excess here. Not terribly proud of this soldering, but it's definitely going to be functional. So, alright, I'm going to stop there while I've got all these connectors made. And I'll take a nice close-up photo of it just to ensure that we don't have any bridging. Now our post QSB is installed. I've gone ahead and reattached the RF board, the video, the power. I'm going to switch the input on my monitor here. And I'm just going to do a test boot. We've connected a lot of stuff to it, so we want to make sure that it's just still functional. So based on that, the fact we're booting up, we know that we at least haven't ruined anything. We've got QSBs installed, the post QSB. The blinking just indicates there's no DVD drive attached. We're still good to go there, so always good to throw a test boot in there. I'm going to power it off, and we'll continue with the process. Okay, so the last bit that we need to install here is actually going to be the JTAG QSB itself, which is this. That we'll place and solder in. I've gone ahead and attached, again, some little adhesive to the back of it. It's actually hanging over the edge a little bit, but no big deal. And the way this will go on will be like so. I'm going to make sure we get it in place before we stick it down too heavily. Oh, you know what I'm seeing here? We're going to connect to that little tiny resistor. So what I want to do is kind of prep it a little bit. Where's my scratch pin? Here it is. So this little resistor is one that we're going to be attaching to. This R2P1, it looks like. So I'm just going to take my scratch pin, try to clean it up just a little bit. Alright, so here's this other point. that we're going to end up with right here. Okay. No way I'm going to attempt to solder it with this port. Hopefully you guys can see all of this pretty well. So what I'm going to do now is go ahead and solder it in place. So we'll add some flux to the relevant points. Some of the soldering is pretty minute. Okay. So we're all turning back cold. Put a little bit more flux on them and hit them with the iron again. Okay.
So that's as much of the installation as I'm really going to video here. You can see I'm getting the final little point there, but the one on the end is so tiny I need to get a better angle on it, so I'm going to do that off camera. What I will throw up here is an image that you can see that shows that tiny little resistor connection there, the first yellow arrow to the left. Be real careful with that. Then the second yellow arrow that's pointing to where it says 2, 1, 3. If you bridge 1 and 2, that's if you're using the standard JTAG wiring. If you, like me, are going to use the odd clamp wiring, which is recommended for Falcons and Jaspers, you'll want to bridge the points 1 and 3. So do not do it like the image that you see here if you are using the odd clamp additional wiring. You want to bridge 1 and 3. If you're using just standard wiring, which would mean no additional wires added on top of the QSB, do it as you see here, which is just 1 and 2. So I'll show you the odd clamp wiring here. So this is the odd clamp wiring. You can see the end of the QSB here, and well as where it runs up to Q2N1, or to the right leg. What's worth pointing out here is you can see the little 1-2 bridge that I'm indicating. I'll put it back up for another moment here, but what that is, that's what you're going to bridge between 1 and 3 in order to indicate that you are using the odd clamp wiring. If you were just using standard JTAG wiring, you would bridge 1 and 2, but as indicated, I'm going to be bridging 1 and 3 because I'm using odd clamp. Also, if you want a slightly closer look at where this wire is running, the Q2N1, you're running to the right leg, as you see here. So the last connection remaining to be made here is the CPU RST line, or the D point, as it will connect to the board. You can see that it's located right very close to the X clamp here. I was able to install it no problem without removing the X clamp, and especially for those of you that it's your first time, I would advise strongly to not try to remove the X clamp, because I've seen boards damaged and need trace repairs from people damaging them trying to remove the X clamps without appropriate tools or know-how. You can see real close in this shot that it's a 2-point connection, so make sure you try to trim it as close to the wire as possible when you solder in that connection. As always, use lots of flux, and it's a pretty easy spot to get connected to. after you've got it installed there, go ahead and tape it down so that you don't have any issues with it being pulled off. There is, however, an alternate for this point. If for some reason you're uncomfortable with the other point or it's damaged but the board is still functional, you can use the R-8C2 side of the resistor indicated in this image. It may be easier for some of you to stick to a top side point, or, as I said, if the other point's damaged. Now that our wiring is complete, our next step is going to be to build a Zell reloaded image. We do that in JRunner by making sure that we have in the right side JTAG, and if you use the odd clamp wiring, odd clamp checkbox selected. In my image it's grayed out, but you'll click the Create Zell Reloaded option. You should see some output, and then it'll say successfully created. From there, we're very simply going to reconnect the NAND pin header wires to the QSBs, power the Xbox, but do not power it on, simply connect the plug to it, and then click the Write Zell Reloaded option. This will write the hack Zell Reloaded file to the Xbox. Now that our Zell Reloaded file is written to the Xbox's NAND, we can finish the installation of the R-JTAG. Really straightforward. The wires are color-coded, they're marked on the QSB and the chip. Install the wires appropriately. Once you have that done, you'll need to take the QSB on the bottom side for the post and run the flat cable around the bottom and up through. Be careful to avoid the SATA port connector for the hard drive. Now that you've connected everything, it's all wired and ready to go, you're actually ready to attempt your first boot. Check your dip settings and your settings for your bottom JTAG from the forum on the TeamX site recommended for your motherboard. Now it's as simple as booting your console. You should be presented with Zell Reloaded if everything works properly and the Xbox glitches or JTAGs. Zell Reloaded will provide you with your CPU key. In my case, I've blurred out the images here, but you'll take that CPU key and plug it into JRunner. Once you have the CPU key, and it's in JRunner, you can then finally use the Create Image function. You want to make sure that your JTAG is selected, the option on the right side, as well as odd clamp if you use that. You can also change your destined dashboard here if you want. Once the image is created, you'll reconnect the QSBs and power the Xbox and write the NAND. This will flash the final hacked image to your Xbox. Once that's done, you have a completed R-JTAG'd Xbox that should boot normally to the dashboard and ready for use.